This started out as a study on paleoecology, but it rapidly became obvious that there was a much bigger story going on. So you're getting two stories in one today. Lucky you. Okay, the context is Ordovician. And so we're in the middle of the Ordovician radiation here, which is a fourfold increase in total diversity, in evolution of new ecosystems, much more increasing complexity. But it's also characterized specifically by a huge diversification of filter and suspension feeders, sessile groups. And these you'd expect sponges from that basis to be a major part of it. So when you go to the published diversity curves, and you see that indeed sponges show this sort of steady increase through the Ordovician, as you'd predict. But if you look at the scale here, that maximum figure is 40 species. This is global compendium of diversity. The highest known level is 40 species back in 2010. So it might be that, given that sponges are a relatively overlooked group, that there's more going on that we haven't quite published yet. So what we need is some real data from the field. So it's going to be based in the Bilfin Lyre in mid-Wales, which, as we discovered last night, is the perfect place to shoot a dragon. And the Hobbit's very good, by the way. It's a small area, about 50 square kilometres, volcanic island system. It's entirely siliciclastic and igneous. There's no carbonates there at all. But it includes the entire history of this island with all the associated deposits and the erosion and reworking of it. And a diverse range of fossils all the way through the system. And we also have several sites with exceptional preservation. This is important for sponges because a lot of them are very delicate. So it's a perfect sort of test area for looking at what the diversity really is in these things, especially as we have a lot of sponges. The localities where we found recognisable sponges are scattered over several kilometres, so it's quite a large area, quite a large number of localities where these are ones where they're recognisable at sort of genus or family level above. And through the sequence, they're fairly evenly scattered through this entire history. So this is where the volcanic island starts, gradually declines and erodes away, and we've got sponge faunas going all the way through this sequence. Sorry, this keeps clipping. So there are several groups that we're interested in, which are only partly taxonomic ones, or partly phylogenetic ones. So demosponges, which are the dominant ones today, 95% of all species of demosponges. A lot of them are amorphous, globular things. They're the typical things you think of when you look at sponges on the coast today. They're not a major part of these communities. In limestones they are, where you get lithistids and stromatoporoids, but not in siliciclastics. These things have always been described as hexaxonelids. However, there's very little direct evidence for this at all, and most of them are probably either stem group hexaxonelids or even deeper. It's a very heterogeneous group, but they're all characterized by thick walls and strange, very robust construction. So they're quite recognizable, but they're not phylogenetically coherent. You've then got things like reticulosans, which are, again, looking like hexaxonelids, but it turns out are not only on the stem group of them, but on the stem group of demosponges and silicia, and probably sponges in total as well. These are primitive sponges, that's what they basically look like. And protomonaxonids are an enigmatic group that used to be classed as demosponges, but aren't. They've got simple monaxon spicules, just single rods, and but they're much larger than demosponges, and they're structured in a completely different way. So we now know that there's some sort of primitive group which is completely extinct. There's also these heteractinids which have sort of 6-rayed spicules, which are very distinctive, but we've only got one articulated specimen of those in 20 years collecting, so we can more or less ignore them. Okay, so shallow water. There's one unique fauna that's already been described from plant ugly rocks, and we've got a similar fauna from elsewhere, a few miles away, which is giving us a bit more context for the rest of it. It's dominated by these very strange things that are known nowhere else in the fossil record. And they're preserved three-dimensionally in a reworked pyroclastic flow, rapid silicification, so you've got three-dimensional structures, sometimes in the soft tissue as well, which is what these drawings were. You've got very peculiar preservation, but the whole fauna is dominated by extremely large, thick-walled things with a central cavity, which is often quite small. Those ones are demosponges. These are these hexaconelid-like things, which may or may not be stem groups, and in many cases they've actually lost the hexactines and just have rods of silica. a bit like proto-monaxenids, but with different structures, so it's fairly clear what the origins are. And this was all described in 2005, except we've now got another half a dozen more species, which we must write up someday, including things like this. I mean, you get the impression these are quite large animals, often 10, 20 centimetres across, with, you can see the spicules preserved here, spicules several millimetres long, which is unusual for sponges. So that was the shallow water. The deep water, we have quite a few assemblages of sponges in different localities. Oh, hello, Peter. And often the localities leave a lot to be desired. This is Wales, after all, not out in Morocco. And you're dealing with little sort of craggy outcrops, which are quite heavily weathered. It takes a while to get into them. But when you do, you find faunas which are dominated by these things, reticulosans. They're often quite beautiful things. And when you have them well preserved, you can't really miss them as long as you look with a lens. I mean, these are very delicate skeletons which fall apart extremely rapidly after death. They have to be buried alive, and in some cases we've got them with the soft tissue as well. So this is the osculum at the top. As Lucy keeps telling me, it looks like a lampshade, basically. But they are quite delicate things. These ones are extremely abundant, but then we start finding that there are a lot of other species as well. The Llanfair Quarries fauna has about 20 species in minimum. We're now finding a lot more. These are all from other localities in the area. Each of them has about 20 odd species of reticulosans alone. It's very large numbers. It takes a long time to get your eye in. They're not easy fossils, but once you do, they become quite obvious in the field. Proto-monaxenids are there as well, but small numbers. Consistently 2 or 3 species at each site, and some quite dramatic things. Others, again, you have to get your eye in, but under a microscope with a lens you can easily see the structure of these with the longitudinal spicules. So they are there too. These are all, the deep water faunas are relatively well known for sponges, and the shallow waters we're lucky in the built-in light to have Llandegli rocks. But, one more thing. We also have, it's turning up that a lot of these things that look superficially similar, when you have really exceptional preservation, are actually completely different animals. And these 3 are all globular forms, pyritized, with vaguely reticulate sort of structure, but you look in detail, and there is the actual arrangement of spiculation there is completely different. So the fine detail of the skeleton, you're looking at quite different sponges. So that's the deep water stuff. But around storm wave base and higher, it's very difficult to preserve these things intact because of their constant agitation. And there are very few faunas worldwide known from a sort of middle shelf water depth. But last year we got quite lucky in finding a new one. There's a little quarry. A farmer had been cutting it out for roadstone for his tracks. And these pale bands are ash beds. The entire upper section here is volcanic ash. The rest of it is mudstones layered between them. And of course it's full of sponges, as they always are. This one is, but this time it's proto-monaxenids. This thing called Koyella is famous in Xinjiang. It's one of the most common sponges there. It doesn't turn up very commonly elsewhere, mainly because of the preservation needed. This one's known only from the Devonian of the US, from one locality, that genus. Then you get more spectacular things. So we have Pyraniids turning up with these enormous sclerite-like spicules all over them. We have basal proto-monaxenids, very simple morphologies. We've got branching things. This is it actually has at least 3 osculi on it, which is a very unusual innovation for these early sponges. The compound things you're familiar with actually came a lot later in the fossil record. And other ones which are a bit more ambiguous. We've got something like 25 species of proto-monaxenid from this site. A few other things as well, reticulosans, but they're quite rare. Only 2 or 3 species of these so far. Again, pyritized preservation, when it weathers, you end up with looking like that. But once you get your eye in for the preservation, they become quite obvious on the bedding planes. It's just that until you know what they are, it's quite difficult to actually recognize them. So in total, what we're getting is, this is the ecological story that we were trying to find in the first place. So we have a very clear distinction between different groups of sponges occupying different water depths. Some of it is well known, these delicate reticulosins in deep water, and we now know that from Plantagenet rocks that you do get these peculiar things in the shallow water, obviously adapted to much more turbulent conditions. We didn't realise before that there were protomonaxonids surviving in huge numbers in the Ordovician. This is a Cambrian group. This is what you expect in the Burgess Shale and equivalent faunas. They're virtually undescribed from the Ordovician and later. So we now have more or less a sequence of onshore-offshore transect showing the diversity. But this is where it starts getting really quite frightening, because this is, if you look at the total distribution of sponges by the number of sites they occur at, we've now got, I think it's 128 of them that are known from one site. And I think it's about 5 from 4 sites or more, or 2 or 3 from 2 or 3 sites respectively. Almost all of the things we're finding are from one site. Compare that with brachiopods or trilobites, and you have a lot of rarities, but an equal number at least of very widely distributed species. These are groups that are well known. They've been studied for 300 years in this area. And so here we've probably got a fairly good record of what is already there. The interpretation of this, well, there's 2 options for the sponges. Either the sponge distribution was incredibly patchy, and that these things were genuinely restricted to individual sites and weren't widely distributed as species, in which case we're missing almost all the diversity because we've only got a few sites. Or that it's sampling a much more diverse background fauna, so sort of random sampling of maybe 100 species which occur widely across these sites, and we're only picking a random sample from each one. In either case, we're seeing only a small proportion of the diversity. And we've already got 128, and we find more every time we go out. So the question is this area normal? Because the built-in layer is a volcanic highland system, lots of silica floating around, and sponges make their skeletons from silica. So you might think that this was a preferential area for them, and it's a curiosity of here. However, we've started to start looking elsewhere, and this is a site from the early Ordovician in North Wales, which is currently just doing revisions, and we have a ridiculous sponge diversity here as well. 40 or 50 species, they completely dominate the biota, and we have soft-bodied animals from here as well, but they still completely dominate the biota. It's absolutely enormous diversity. And you need exceptional preservation to find them, but when you do get that level of preservation, they seem to be enormously abundant in the Ordovician in Wales. For comparison, we started looking in the Silurian around mid-Wales. So the same sequence, it's part of the same history of the Welsh Basin. It's relatively deep water, offshore, and we have preservation of things like complete crinoids, various other echinoderms, got Volcoviid-like things, rhombiphilums and so on. We're finding new faunas quite widely in this area, but we never find sponges. I think we found 1 or 2 spicules so far in the entire Silurian sections that we're looking at. So whatever this was, it seems to have been a phenomenon restricted to the Ordovician. Okay, so first part of the conclusions, the ecology, we've got definite proof that these different sponge groups had different environmental preferences, which is nice to confirm because it's the same as what we see in the Cambrian, but most of these groups were thought to have gone extinct by the end of the Cambrian. But we've got high alpha diversity at most sites, enormously high beta diversity, and to give you an idea, comparing with the global diversity curves again, this is slightly modified with some of our new faunas added to the global diversity curve. So the moral here is we really don't have a clue about sponges at all. And if this is typical, we don't know yet. It might be that the Welsh Basin was sponge paradise. But if this is typical, and we have no reason to assume a priori that it isn't, then we're missing a huge part of Ordovician diversity. And in terms of the ecology, where we find the sponges, they're often among the most dominant groups as well, far more common than trilobites are, especially when you take into account molts and so on. So what we've got here is something which could completely change our interpretation of ecosystems, in terms of how the ecosystems worked, how the nutrient flux worked, if this is a genuine pattern. And I think I'll leave it there. We need some more data, please.